Learning target 10. Be able to solve a linear inequality with multiple steps and graph the solution on a number line. Inequalities are solved the exact same way equations are solved, with two exceptions. If you multiply both sides by a negative number, you have to flip the inequality sign. If it was a greater than, you change it to a less than. If it was a less than, you change it to a greater than. And if you divide both sides by a negative number, you flip the inequality sign. Greater to less, less to greater. That seems real simple to keep in mind, but it's kind of hard to put into practice sometimes. So let's do some examples to make sure that we flip the inequality sign only when we're supposed to. That's the biggest problem. It's not that people forget to flip it. It's usually that you flip it when you're not supposed to. That tends to be the bigger problem. All right, so copy these examples down with me as we go. So let's do this first one here at the top of the screen. We're supposed to solve negative 11y minus 13 is greater than 42. Now, if that was an equation, you would start off, there's no simplifying to do on either side. You'd start off by adding 13 to both sides. That's what we're going to do. So we get negative 11y is greater than, now when I add 13 to both sides, on the right side I need to add 42 plus 13. Well, what is 42 plus 13? 55. I did not change my inequality sign, did I? But I'm getting ready to, because now I need to divide both sides by a negative 11. When you divide by negative 11, you change your greater than to a less than, and then 55, positive 55 divided by negative 11 will be negative, and then what's 55 divided by 11? 5. So what this means is that any y that's less than negative 5, like negative 6, negative 7, negative 1 million, can be substituted in for y, and you'll get a true statement out of it. Okay? Just like when an equation, if we got y equals negative 5, we'd say, hey, if I replace y with negative 5, I get a true statement. Now we're saying replace y with any number that's less than negative 5. We get a true statement. Now, part of our learning target was to be able to graph the solution on a number line, which we don't do with equations. But here's all I'm talking about. It's not complicated. You make a number line, you put negative 5 on it, and then just put one number to each side. Put negative 4, one to the right, negative 6, one to the left. Now, less than, doesn't say less than or equal to. So negative 5 is not actually a solution. But everything less than negative 5 is. Now, where are the numbers less than negative 5? To the left or to the right? And that's all you got to do. That's the graph of the solution. Okay? And I do want you to do that because it's important that you realize that less than and to the left are the same idea. Greater than and to the right are the same idea. You really need to understand that. Okay? All right, let's do another one. 2a. We have 23 is greater than or equal to 10 minus 2w. If this was an equation, there's no simplifying to do on either side. We would start off by subtracting 10 from both sides. So let's do that. 23 minus 10 is 13. Leave that as a greater than or equal to. And then 10 minus 10 is 0. Negative 2w. Okay? Now, I need to divide both sides by negative 2. When I divide by a negative number, that greater than or equal becomes a less than or equal, and then 13 divided by negative 2 will be negative, and I could call it 13 halves, but it's 6.5, isn't it? You want to just go ahead and call that 6.5? And then W. So I divided both sides by -2, and I flipped the inequality sign. The only trouble with that, this particular problem, is that the solutions are more difficult to graph. They're more difficult to visualize when the variable's on the right. With an equation, I don't care if the variable's on the right instead of the left. With an inequality, I do. So watch what I'm going to do here. I'm going to put the W on the left. I'm going to put the -6.5 on the right. But what should my inequality sign be? Well, you probably heard when you were younger, the alligator eats the bigger number. Did you ever get told that? Think of that as these are the jaws of the alligator. There's the alligator. There's his legs. All right, so there's the alligator. It's eating the W. It's going to continue eating the W, so it's got to open up and eat the W. So that silly sign just kept getting flipped, didn't it? Did what? Yes, because that's a pretty good alligator. Because to graph it, it works a lot better if you can think of it this way. If W is greater than or equal to -6.5, so let's put that on there. Let's put -6. Let's put -7. I don't need to make an entire number line. First off, the or equal to part means that -6.5 is included in the answer this time. Now, greater than. Where are the numbers greater than? To the right. That's why the variable needs to be on the left, so that you can ask yourself, where are the numbers greater than -6.5? To the right of -6.5. Now, unfortunately, over the years, what I've learned is you see one problem where it looks like the sign's getting flipped every step. I can't tell you how many quizzes I've given over the years where you get an inequality and a student will flip the sign every step, whether they're supposed to or not. Which means at the end, they got a 50-50 chance of being right and a 50-50 chance of being wrong, even if they've done everything else correct. So you only flip it when you divide or multiply both sides by a negative. And then, I guess there's a third exception, huh? Get the variable on the left to do that. You'll have to flip it when you do that. If the variable was on the right, you'll have to flip it to get it on the left. All right, let's do 2b. It's another one where the variable's on the left. But that's okay to start with. Shouldn't we subtract 11 from both sides to get started? What's 43 minus 11? So 32 is greater than -4y. Divide both sides by -4. What is 32 divided by -4? So -8 is greater than y. But that's harder to graph than I want it to be. So I want to put the y there and the -8 there. The alligator's eating the -8. Keep the alligator eating the -8. Now when I graph this, I'll just put -8 on there. I'll put one number to the right, one number to the left. Do I close the circle, which means fill it in, or leave it open? Open to the left or to the right? Less than, left. Numbers less than or to the left. Okay? Questions so far? Define a variable, which means say what x equals, write an inequality, and solve the problem. 5 minus 6 times a number is more than 4 times a number plus 45. So what is it that we don't know? We don't know the number. So guess what x is going to equal? The number. Now let's start to say an equation. It's not going to be an equation, it's going to be an inequality. Now let's write an inequality. So let's start back over here. 5 minus 6 times a number. So 5 minus, if our number is x, 6 times x, 6x is more than, would that be greater than or less than? Is greater than, and then 4 times a number plus 45. 4 times x plus 45. Okay? That inequality make sense to you? Now, when I solve these, now that I have an x on both sides, I'm going to do something that I didn't bother doing on these two, which is, since I'm going to have to get the x on one side or the other, I might as well get it on the left, because that's where we want it on the last step, isn't it? So, with an equation, I'd probably add 6x to both sides, but since it's an inequality, I'm going to subtract 4x from both sides so that the x ends up on the left. That'll save you a step of work later on down the problem, okay? So leave the 5 there. Negative 6x minus 4x is negative 10x, is greater than. 4x minus 4x is 0. Keep your 45. Subtract 5 from both sides. On the left, negative 10x is greater than, I have not flipped the sign, and then 45 minus 5 is 40. Now, divide both sides by negative 10. I'll get a positive x. I have to switch my sign to a less than, and 40 divided by negative 10 is negative 4. So any number that's less than negative 4 solves the problem. So on a number line, put negative 4, put one number to the right, one number to the left. Open circle or closed circle? Open to the left or to the right? To the left. So far, so good. Now, we might have to do more simplifying. So, here's an example with the distributive property involved. 4 times the quantity, 3t minus 5, plus 7 is greater than or equal to 8t plus 3. They're giving us a hint here that it's the distributive property we need to use. On the left side, we're going to simplify before we solve. Multiply the 4 times 3t and get 12t. Multiply the 4 times the negative 5 and get negative 20. And then just copy down the rest of the problem. We're not through simplifying on the left, though. Negative 20 plus 7 is negative 13. Now, I'd rather have my variable on the left side. Since I would prefer to have the variable on the left side, I need to subtract 8t from both sides, don't I? So that there's no t on the right anymore. 12t minus 8t is 4t. Copy down the minus 13. Copy down the greater than or equal to. 8t minus 8t is 0. Copy down the 3. Do I need to subtract 13 or add 13? Add. So 4t is greater than or equal to 16. Divide both sides by 4. How many times did I flip my inequality sign during this problem? Never. 0. So I made sure I included one where I didn't. Because, I mean, let's face it, they're going to make you flip your sign fairly often. But not all of them need to have a flip sign ever. This one didn't. All right, so graph it. Put a 4, put one number to the left, one number to the right. Open circle or closed circle? Closed on the 4, to the left or to the right? So any number to the right of 4 or including 4 will make a true statement for this inequality. No, never flip it for adding or subtracting. And never flip it either, even if this had been, look up here, even if that had been a negative 4 I distributed, don't flip it then either. It's only when you multiply both sides by the negative number. Right. The flipping only comes from multiplying both sides by negative or dividing both sides by negative. Or if your variable's on the right at the very last. Okay, so those 3 exceptions. Other than that, don't flip it. So if you're not sure, don't flip it. Okay? All right, let's see. I've forgotten which one of these is the hardest. Oh well, let's do them both then. So, for A, I need to start off by distributing. Distribute the 6. 6 times 5z will be 30z. And then 6 times negative 3, negative 18, is less than or equal to 36z. And then here we have a decision to make. What's that? We can either subtract 30z or we can subtract 36z. Each one has its own issues. By subtracting 30z, which is what I really would rather do, that means at the very end my z is going to be on the right and I'll have to flip the whole thing. We okay with that? Or I could have subtracted 36z, but then let's subtract 30z. And I'll see how this works out. So subtracting 30z, the left side is now negative 18. The right side, 36 minus 30 is 6z. Divide by 6, not negative 6. Divide by 6, I get negative 3 is less than or equal to z. Which there's nothing wrong with that other than we like the variable on the left when we solve an inequality. So flip it now, flip the whole thing, not just the sign. The whole thing gets flipped like that. Close or open? Left or right? Now, instead of working 4b, let me just work this one for you again. If at this point where I had 30z minus 18 is less than or equal to 36z, if I'd made the other choice, if I had decided instead to subtract 36z, how would it work out? 30z minus 36z would be negative 6z minus 18 less than or equal to, and then 36z minus 36z is 0. The next step, I would add 18 to both sides, so I get negative 6z is less than or equal to 18. And now I divide both sides by negative 6. When I divide both sides by a negative, I flip the sign. And then 18 divided by negative 6 is negative 3, and I got the exact same answer. Does it matter which way I do it? No. Don't do some mashup, though, of both methods and end up flipping the sign either one time too many or one time too few. Okay? Everybody with me? All right, let's do one of these really complicated ones. Let's do A. We got a lot of simplifying to do here. So I've got 9t, and then minus 5 times the quantity t minus 5. I need to distribute that negative 5, don't I? Negative 5 times t is negative 5t. Negative 5 times negative 5 is positive 25. Less than or equal to. Then on the right side, I need to distribute that 4. So I get 4t minus, what was it? 12. Now, I'm not finished simplifying, because on the left side, 9t minus 5t is 4t. So 4t plus 25 is less than or equal to 4t minus 12. Subtract 4t from both sides, and something that we don't really like happens. We get zeros for the t's, don't we? So we get 25 remaining. We get our less than or equal to, we get negative 12. Just like with an equation, when all of a sudden your variables are gone, either there's no solution or everything's a solution. It depends on whether or not that's a true statement. If that's a true statement, every possible t is a solution. If that's a false statement, there is no solution. Which is it in this case? That's a false statement. 25 is not less than or equal to negative 12. So that's a false statement, so there is no solution. But let me emphasize it again. If we had come up with a true statement, we would say the solution is all numbers. Okay? If the variable's gone and it's a true statement, the solution is all numbers. Got it? All right. Then I've got a little worksheet for you. I'm sure you're surprised by that.